So in this video, you're going to learn how to simplify radicals. You're going to learn what a radical is, you're going to learn why we're simplifying radicals, and you're going to learn how to connect it to the last video, which was solving square root and cube root equations. This is an algebra topic, so I'm hoping that if it's a little difficult, we can work through it tomorrow in class, and everything should be okay. Have fun. So we're going to look at simplifying the square root of 32 into its simplest form. And reducing a radical, so a radical is either a square root or a cube root or something that has this root box. The general term for those is radicals. So in this case, we could say rad 32 or the square root of 32 because it's specifically a square root, but the rad box shows you, or the square root box is also called a radical. So I'm going to look at reducing this. When I reduce or simplify a radical, my goal is to factor out all of the perfect squares. So because my number is 32, I'm going to write all of the factors, all of the perfect squares that are equal to or less than or equal to 32. So I stop at 25 because the perfect square after 25 is 36, and 36 is larger than 32. So I'm going to be looking in this list of numbers, and I'm going to be asking myself, what is the largest factor of 32 that I see? Well, 4 is a factor of 32, 9 isn't a factor of 32, and 16 is a factor of 32, 25 is not. So I know that 4 and 16 are both, and 9 and 25 are not. I'm going to go with the largest, which is 16. So in this case, I have the square root of 16 and the square root of 2, which which multiply together to give me 32. Even though 2 is not a perfect square, 16 is. And it's the largest one that divides into 32. The square root of 16 gives me 4. And the square root of 2 is just going to stay as the square root of 2. So the square root of 32 is going to equal 4 rad 2. If I was given the square root of 75, I would look at my square root list for the largest perfect square that goes into 75. Remembering that I can stop listing my perfect squares when I get to a number that is the same or larger than 75, because I know my factors have to be 75 or smaller. So the next factor after 64 would be 81. The next perfect square after 64 would be the square root of 81, and 81 would be larger, so I know that it couldn't be. When I look at the list of perfect squares that I have listed out for a factor of 75, 1 is always a factor. I don't know why I include it. It is a perfect square, but it's always going to be a factor. Most of the time you're going to get larger ones. So 1 is a factor, 4 is not, 9 is not, 16 is not, 25 is, 36 isn't, 49 isn't, 64 isn't. So the largest and only perfect square that is on my list is the square root of 25. So I have the square root of 25 and I have the square root of 3. Square root of 25 gives me 5. Square root of 3 gives me the square root of 3. So the square root of 75 as a simplified radical would be 5 rad 3. So if I were to do the square root of 20, again, I'm going to list them. I'm going to stop when I get to the square root that becomes larger than 25. Larger than 20, which is 25. So I know I'm going to look at this list and I'm going to say, is there a perfect square that goes into 20 that is a factor of 20? Obviously 1 is, 4 is, 9 isn't, and 16 isn't. The largest one is the square root of 4. So I say there's the square root of 4 and there's the square root of 5. The square root of 4 gives me 2. The square root of 5 gives me the square root of 5. So the square root of 20, or rad 20, equals 2 rad 5. So I want to make a connection for you as to why you are learning this, because most of us are probably saying to ourselves, why am I doing this if I can just get out my calculator and do the square root of 32, round to the nearest 10th or 100th or whatever the directions say, and then I'm done. Well, as you get further into algebra, you're going to be asked to add or subtract radicals. And the only way that you can add or subtract radicals is if you have the same number left underneath the radical after you simplify it. So we've already done the square root of 32 as the square root of 16 and the square root of 2, which left us with 4 rad 2. Then, if you do the square root of 50, you have the square root of 25 and the square root of 2. If that doesn't make sense to you, remember to list out all of your square roots. And when you can stop after you get to this perfect square that is the same or larger than the number that's underneath your square root box. So as I keep going, I get to 64. 64 is larger than 50, so I know that can't possibly be a factor. I look at my list and I say, oh, 25. And then I say, well, what times 25 is 50? 2. So then I have rad 25 and rad 2. And that reduces to 5 and rad 2. So that would be 5 rad 2. So the only way that I can add rad 32 and rad 5 is if and only if, when I simplify the radicals, the numbers that stay underneath the square root box are the same. So in this case, they're both 2. Think about them as variables in the sense that if you had 4x plus 5x, because the x's were like terms, you could add them by saying 4 plus 5 is 9 and the x comes along for the ride. You couldn't add it if it was 5x, 4x and 5y. Just like you couldn't add these two simplified versions if this was 4 rad 2 but this was 5 rad 3. You can only simplify them if the number that remains underneath the radical is the same. And because in this case it is the same, you're going to add the coefficients, and I put those in quotes even though you can't see my fingers, but the numbers that are in front of the radicals, you're going to add them. And then whatever number is underneath the radical is going to come along for the ride. That means that if on your calculator you did the square root of 32 and you added to that the square root of 50, which is the original expression that we have, whatever that number you get on your calculator after pressing equal should be the same as what you get if you press 9 times rad 2, because 9 rad 2 means 9 times rad 2. You do not have to know how to add or subtract radicals, but I wanted to show you what's to come as you get further into algebra. So here's how this links to what we did in the last video. If you were asked to solve this equation, you would take the square root of both sides because that's the inverse operation of squaring. And when you got that, you would get y equals plus or minus 108. Before, and if you were asked to round to the nearest tenth or hundredth, you would plug the square root of 108 into your calculator. And when you plugged it into your calculator, you would get that x equals plus or minus 10.39 ... So depending on what you were asked to round to, your answer would either be 10.39 because the next number happens to be a 2, or your answer would be 10.4, depending again on what you round to. Now, if the direction said to you, solve and simplify the radical, you would say, okay, I'm going to look at 108, and I'm going to see which of the numbers, which of the perfect squares of the largest, which is the largest, that will be a factor of 108. Remembering that I'm going to stop when I get a number that is the same or larger than 108. I get out my calculator, I divide 108 by 4, it goes in, it's a match. But I keep going just to make sure. 108 divided by 9, it's also a match. So now I know 4, I don't want to use 4 because 9 is larger. Then I go 108 divided by 16, nope. 108 divided by 25, nope. 108 divided by 36, yep. So I don't want to use 9 because 36 is bigger. 49, nope. 64, nope. 81, nope. 100, nope. And obviously 121 because it's larger, nope. So I now know that I'm going to use the square root of 36, and 108 divided by 36 gives me 3. So then I take the square root of 36 because that's a perfect square and gives me a whole number. And then the square root of 3 comes along for the ride. So my final answer would be plus or minus 6 rad 3.